we are in the third class of state space analysis. In fact, we can say third problem solving class of state space analysis. Eigenvalues of the matrix A1 A1 are. There are four alternatives given, and this question has been asked in GATE 1994. So the system matrix A is given as A equal to A1 A1. Now the eigenvalues are given by as we know, the eigenvalues are given by determinant of Si minus A equal to 0. So what is Si minus A? So Si minus A, this will be equal to S multiplied by I. Here, since A is 2 cross 2 matrix, so I will be a second order identity matrix. So Si minus A is nothing but Si minus A1 A1. Now it will be S0 0 S minus A1 A1. So it will be finally S minus A minus 1, S minus A minus 1, minus A here, S minus A, S minus 1, sorry. So the determinant from here, now we have got the value of Si minus A. So from here, now we can write, since the determinant of Si minus A, so now we can write from here that S minus A multiplied by S minus 1 minus A multiplied by minus 1. This is equal to 0. So if we multiply this by this, so it will come S square minus A plus 1 S plus A, and here this will come minus A equal to 0. So how much it will come? S will get common. So S minus A plus 1. This will be equal to 0. Now this implies either S equal to 0 or S equal to A plus 1. So which option is the correct one? So correct option is option number A. Now the next question is the matrix of any state space equation for the transfer function Cs divided by Rs of the system shown below in figure is. So it is asking about the state system matrix, and this question has been asked in GATE 1994. So let us try to solve it. So it is given that this is a unity feedback system with a constant gain of 3 is in cascade with this unity feedback system. So now we can write that now we can again draw the graph block diagram. So it is RS, and here this is plus minus. So it is 1 by S. Now it is CS. Now if we see the transfer function for this block only, which I have encircled within the dotted line. So the transfer function for this block will be nothing but it will be, this is GS and HS for this is 1. So GS divided by 1 plus GS into HS, because this is a negative feedback system, negative unity feedback system. So now we can write the transfer function of the whole system as 3 multiplied by the transfer function of this dotted system. So transfer function Ts is equal to nothing but 3 multiplied by the transfer function for this system. The system between dotted line is Gs means 1 by s divided by 1 plus Gs into Hs is 1, since it is unity feedback system. Now we can write from here that 3 into 1 by s divided by s plus 1 by s. So s and s get cancelled out. Now we get 3 by s plus 1. Now this is now Ts equal to 3 divided by s plus 1. Now this is a first order system. This is a first order system, and if we write the state space equation for this system, then the system matrix A will be nothing. The system matrix A will be first order matrix, and it will be nothing but it will be minus 1. So the system matrix for this transfer function will be, means the system matrix will be A equal to minus 1. So the system, why I am saying minus 1? Because this is a first order system and denominator is containing s plus 1, so it will be minus 1. Because if you write like this ys divided by us, suppose you write it as ys divided by us. So what is this? This is 3 by s plus 1. So what is this? S into ys plus ys equal to 3 us. So s into ys is nothing but y dot s. So it is y dot s plus ys minus 3 into us equal to 0. Now if we take ys as x1, so if we take ys as x1, let me write here. If we take sorry, let me write by black pen. If we take x1 equal to ys, then y dot x is nothing but this is x1 dot, then x1 dot equal to minus ys plus 3 us. So what is this? Ys is nothing but x1, so minus x1 plus 3 into us. So now we can write here x1 dot equal to minus 1 into, in matrix form it is x1 plus 3 into us. So now here also the system matrix is minus 1. So what will be the answer? The answer is A. C. Consider a second order system whose state space representation is of the form x dot equal to ax plus bu. If x1 t equal to x2 t, then the system is. So and there are 4 alternatives given, and this question has been asked in GATE 1993. So here in this question it is given that there are 2 state variables. First one is x1 and second one is x2, and both state variables are equal. Now let me write here x1t, this is equal to x2t. Now this implies if we differentiate both the sides, then x1 dot t will also be equal to x2 dot t. Now since x square equal to x dot is given that x dot equal to ax plus bu. Now suppose we consider system matrix A as we can write here this is x1 dot and x2 dot. Now suppose system matrix A as a1 a2, or you can say a11 a12 a21 a22 x, this is x1 x2. Now let me write this b as b1 b2 u. Now it is given that x1 dot is equal to x2 dot. So now from this equation we can write x1 dot is nothing but this row get multiplied by this column. So a11 x1 plus a12 x2 plus b1 u. This is x1 dot. Again x2 dot equal to a21 x1 plus a22 x2 plus b2 u. Now these two are equal, since because x1 dot is equal to x2, x1 dot t is equal to x2 dot t. So now we can write from here we can write x1, since x1 dot is equal to x2 dot. This is nothing but a11 x1 plus a12 x2 plus b1 u. This is equal to a21 x1 plus a22 x2 plus b2 u. Now since again it is given that x1 is equal to x2, so if we convert all the things, if we write all the things in x1, then what will happen? Then a11 x1 plus a12 x1 plus b1 u minus a21 x1 minus a22 x1 minus b2 u. This is equal to 0. Now a11 plus a12 minus a21 minus a22 x1 plus b1 minus b2 u equal to 0. And this can be only possible when the term within the first bracket and the term within the second bracket are both equal to 0, are both separately equal to 0. This implies a11 plus a12 minus a21 minus a22, this is equal to 0. That is a11 plus a12, this is equal to a21 plus a22. And from here b1 minus b2 equal to 0, that is b1 equal to b2. So now we are with conclusion that a1 1 plus a12 is equal to a21 plus a22 and b1 equal to b2. Now let us check the controllability and observability of the system. So now for at first we will check the controllability of the system. So controllability means we have to calculate the matrix QC. So for control, let me write here. So for controllability check, for controllability check, we have to form the matrix QC, and matrix QC is nothing but this is B partition A B, right? So now what is B? B is nothing but B1 B2, and what is AB? So we have to calculate first AB. So AB equal to A11, A12, A21, A22, and what is B? B is B1 B2. So how much it will come? So it will come like A11 B1 plus A12 B2, again A21 B1 plus A22 B2. Okay. Now QC is equal to, what is B? Matrix B is B1 B2. So it is B1 B2. A11 B1 plus A12 B2, A21 B1 plus A22 B2. Now if B1 and B2 are equal, since we have reached on this the conclusion that B1 is equal to B2. So if B1 and B2 are equal, then these two elements become equal and these two elements become equal. So the first row is equivalent to second row. If B1 equal to B2, then we can replace, suppose we replace B2 by B1. So what will happen now? Let me write here B1, here also B1. Now A11 B1 plus A12 B1, A21 B1 plus A22 B1. Here I should write, since B1 equal to B2, so we have replaced B2 by B1. Now if we take, this is B1. Now if we take B1 as common, A11 plus A12 here, B1 here, B1 A21 plus A22. Now since again A11 plus A12 is equal to A21 plus A22, so both the rows are same. And the determinant of QC will equal to 0, since both the rows are same, and hence we can say that the system is not controllable because the rank of QC is less than 2. So we can write here determinant QC is equal to 0, hence system is uncontrollable. Hence system, and hence from here we can write hence system is uncontrollable. We should write here hence system is not controllable. So which option is correct one? Uncontrollable. So we don't have to check for observability because we have got the answer uncontrollable, and since it is single answer, multiple choice question with single answer, so there is no need to check for observability and stability of the system because we have got the answer in our first search. So there is no need to go for other searches. Now all of you know about what is controllability and observability. If you have any problem in controllability and observability, then go through my class, my uh, control system class. There I have explained clearly what is controllability and observability of a system. Is given by, there are four alternatives given, and this question has been asked in GATE 1993. So what is x dot? So x dot is equal to ax plus bu. Now if we take the Laplace transform of both the sides, so taking Laplace transform of both the sides, how much we get? This will be s x s equal to a x s plus b u s. Here note that we have taken the initial condition, all initial conditions 0, because since we are calculating the transfer function, so the definition of transfer function itself is the Laplace transform of output divided by Laplace transform of input, taking all initial conditions 0. So I have taken all initial conditions 0. So from here we can write, if we take this term in left side, so we can write Si minus A, where I is the identity matrix. Si minus A xs, this will be equal to bus. Now if we multiply by the inverse of Si minus A, so it will be multiplying here, let me write multiplying both the sides by Si minus A inverse. We get, how much we get? We get this left side as xs and right side as Si minus A inverse b us. Now again it is given that y equal to cx plus du. Again y equal to cx plus du. So this is equation number 1, you can say. Now again taking Laplace transform of both the sides. So taking Laplace transform of both the sides. So it will be ys equal to cxs plus dus. Now from 1 we have to put the value of xs. So this implies ys equal to c, xs is nothing but si minus a inverse b plus csi inverse b us plus d into us. We should write here from equation number 1. Now this implies ys. Now here we have to take us common, so it will be c si minus a inverse b plus d us. Now if we take us in left side, then ys divided by us, this will be csi minus a inverse b plus d, and the ratio of this Laplace transform of output divided by Laplace transform of input is nothing but this is only the transfer function. So the transfer function is this one, CSI minus A inverse B plus D. So which option is correct? So CSI minus A inverse B plus D. This is not correct. This is not correct. So CSI minus A inverse B plus D, because the addition of matrix can be interchanged. So option number A is correct one. The next question is a system matrix given as follows. This is the system matrix. The absolute value of the ratio of maximum is. So the absolute value of ratio of maximum is. This is a fill in the blanks type question, and the question is asking about the absolute value of the eigenvalues. So what is the absolute value of the ratio of eigenvalues, the maximum ratio of eigenvalues? So at first we have to calculate what are the eigenvalues, then we have to calculate their ratio, and then we have to calculate what is the maximum value of that ratio. So the eigenvalues are given by determinant of matrix Si minus A, this equal to 0. Now we have to calculate the matrix Si minus A. Now Si minus A, this is nothing but S into 1 0 0 0 1 0 0 0 1, because this is the identity matrix of third order, minus A. What is it? A is nothing but 0 1 minus 1 minus 6 minus 11 6 minus 6 minus 11 and 5. So if we calculate, then it will give S minus 0. So and here 0 minus 1, so it will be minus 1. Here again 1. Now here 0 minus 6, so it will be 6. Here S minus 11, so S plus 11, it will be S plus 11. So and here 0 minus 6, so it will be minus 6. Again here 0 minus 6, so it will be 6, it will be 11, and it will be S minus 5. Now if we calculate the determinant of Si minus A, so it will be equal to, it will be nothing but S into here S plus 11 into S minus 5 minus 11 into minus 6 minus 1, so minus 1, so minus 1 into here we have to cover the second row, the second column and the first row. So it will come 6 into S minus 5, 6 into S minus 5 minus this 6 into this minus 6, 6 into minus 6. Again 1 plus 1 into, if we cover the third column and the first row, then it will come 6 into 11 minus 6 into S plus 11. 6 into 11 minus 6 into S plus 11. Now how much it will be? So S into, if we multiply these two terms, so S square minus 5S plus 11S, so S square plus 6S minus 55 plus here 66 plus here 6S minus 30 and here plus 36. Now here, how much we will get? Plus 66 minus 6s minus 6x minus 66. So 66 will cancel out each other. Now here now we can write this as s cube plus, what is this, 6s square plus 11s plus 6s plus 6 minus 6s. So now s cube plus 6s square plus 5s, here we have got s square plus 6x, so here it is 6s plus 11s, again here from here 6, so 11 and 6x s will cancel out each other, so we have to write here 11s plus 6. Now since from here, since determinant si minus a equal to 0, so let me write 1, this 1. So from 1 s cube plus 6 s square plus 11s plus 6 equal to 0. Now we have to calculate the values of its root. So what will be the values of roots? Since calculator is allowed in GATE exam, so you can directly calculate the value of roots of any equation by the use of calculator. So if you calculate by the calculator, then the value of s will come 1, 2, 3. So it will come like minus 1, minus 2, minus 3. So s will be equal to minus 1, minus 2, minus 3. So the maximum value of ratio of eigenvalues is, so ratio of maximum, now we can write ratio of maximum, this will be equal to magnitude of minus 3 by minus 1. So it will be nothing but 3. So now we have to write the ratio as 3. Now at the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video, so that there is no need to search out new video. Automatic update will come if I upload the new videos. What you have to do, it is very simple. There is a circular logo coming in right of me. You have to just click on that to subscribe.